All right, so today our objective is that you're going to know what the Pythagorean theorem is by this end of this lesson, and you'll be able to use it to determine missing side lengths. So real quick, before we start, two things I would have ready is if you're going to print the notes, to go ahead and get those printed from Schoology to fill them out as we go. If you are going to just copy notes as we go, your paper, your pencil, whatever you're going to use to take your notes, and I would have your calculator ready, and if you have a phone with a calculator, that's perfectly fine. So today we're talking about the Pythagorean theorem. So in a right triangle, the two sides adjacent to the right angle are known as your legs, or A and B. So this is our right angle. A right triangle is a triangle with one right angle, a 90-degree angle, and we talked about last week that those two lines in the corner there show you, and they designate to tell you this is a right angle. So these two sides formed by that right angle are your legs, which are your A and your B. And it doesn't matter which of the two of those I label A and which of the two of those I label B, as long as they are the two sides attached to the right angle. So then our side opposite from the right angle is called the hypotenuse. Hypotenuse, or C. And this is our important one. It has to be the side across from that right angle. So if you have to take your right angle, draw straight across, that's your C. The hypotenuse is always the longest side of that right triangle. All right, so then the Pythagorean theorem tells us how the side lengths of right triangles are related. So in any right triangle, the square, and if you don't remember back in quarter one when we talked about squares, is a number times itself. So the square of the hypotenuse is equal to the sum of the squares of your legs. So it says of the other two sides, the square of the two legs. So more simply stated, we're going to be using the formula leg squared. So A and B, leg squared plus leg squared equals that hypotenuse squared. So A squared plus B squared equals C squared, because we know A stands for one of our legs, B stands for one of our legs, and our C is our hypotenuse. So let's go ahead, well, real quick. If you are still, let me move this. You are still copying that, go ahead, pause this, finish filling in those notes. And then we will get started by just getting to know our right triangles. So I'm going to go ahead and do one, and then I'm going to have you guys pause this and fill in the other three. So here is our right angle. We know the side across from our right angle is our C. And then, like I said, it doesn't matter which of those two sides you label A and B, as long as they are your sides. And those lines mean that they're the same, and we don't know that. But that as long as your two sides attached to that right angle are A and B. I could have flip-flopped A and B, but the C has to be that longest side across from your right angle. So now what I want you to do is go ahead and pause this and label your other three triangles. Okay, so by now you've paused it and you've done this. Otherwise, do it now because I'm going over it. So our side across from our right angle is C, our hypotenuse. And then again, our A and our B could be either of these. You could have flip-flopped them. As long as you have this one as C, has to be the side across the right angle. So again, this one has to be C, our hypotenuse, our longest side across from our right angle. And our other two sides are A and B. And it doesn't matter if you did it, you had your A and B different, you had your B here or your A here, as long as the C is here. And then one more time, same thing. Across from our right angle is our C. That one has to be there. And then you could have put A here or B here, and then B here or A here. All right, so now we're going to practice using our Pythagorean theorem to find missing side lengths. I'm going to do two with you, and then I'm going to have you pause it and attempt the third. So this is the first way you might see the Pythagorean theorem, is where you have two legs, and I'm going to put an X here because we don't know what that third side length is. So we're going to use the Pythagorean theorem to find the missing side length of each triangle. And I wish they had labeled this, but that is our right angle right there. So we know that the missing side length is our hypotenuse. So I'm real quick going to have you do this just because I don't like that they did it that way. They want you to assume that those are right angles, but as you get further in the math, into high school, they're not going to let you just assume. So those are our right angles. So in all three of these cases, we're looking for our hypotenuse and not a leg. So we know our Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So we have two of our three lengths, which means that if I have two of them, I can find my third. So now we're going to plug in one of our legs, so 3 squared. We're going to plug in our other leg, so 4 squared is equal to that missing side length squared. Well, 3 squared, or 3 times itself, so 3 times 3 is 9, plus 4 times itself, so 4 times 4 is going to be 16, is going to be equal to that side length squared. And as we get further, if you look at that next one, 24 squared, we're going to plug that into a calculator, but these are small numbers we can do in our head. Pythagorean theorem is a little bit harder, so it's understandable if you want to square these numbers in your calculator, but I can square 3 and 4 in my head just fine. And then I know 9 and 16 is going to give me 25 equals c squared. So I don't want c squared. I want to know what c is. So once I get to the end of my equation, my last step is to get rid of that squared. So what I have to do is take the square root of both sides. Well, what times itself gives me c squared? C. So the square root of c squared is just c, which is what we're looking for. So once I have that square root of 25, I know what c is. So I'm going to go ahead and pull up my calculator. I already know that the square root of 25 is 5 because 5 times 5 gives me 25. But I want you guys to get some practice figuring out the square root in a calculator. So on your computer calculator, you would type in your 25. You would look for this little square root. So you have an X and you have your square root symbol. It's got the little 2 to show you you're talking about square roots. And you'd hit square root. And it's going to tell me that the square root of 25 is 5. So that missing side length, or our hypotenuse, or C, I don't know why I put, and normally I use the variable C or A or B, whichever side. I forget about X when we're talking about Pythagorean theorem so that we can keep our letters straight and don't throw a bunch of them in there. But our C side, or our hypotenuse, is going to be 5, and they're all in inches, so 5 inches. All right, so we're going to do one more together, and then I'm going to have you pause this and try one on your own where you're finding the hypotenuse. All right, so again, leg are 2 sides attached to that right angle, and the side across from it is our C. So we're missing our hypotenuse. In all 3 of these examples, we're missing a hypotenuse. After we go over this, we'll talk about missing legs. But, so we know either leg, it doesn't matter the order, 24 squared, because addition, we know the order in addition doesn't matter. So leg squared plus leg squared is going to give us hypotenuse squared. All right, so and this is what I'm talking about. We're just going to go ahead and say, well, 24. So the X with a little 2, a little squared symbol, we're going to go ahead and plug that into our calculator. So it tells us the square of 24 is going to be 576. So 576 plus, I do not know why I put 7 to the A, plus 7 squared. And 7 times itself is going to give us 49 is equal to C squared. And we can go ahead and say 576 plus 49 is 625. And can anyone off the top of their head tell me what number times itself gives me 625? No, you can't. So we don't want C squared. We want to know what that side length is. So we have to take the square root of both sides. I know c times c is going to give me c squared. So the square root of c squared is just c. And then we're going to go ahead and say, well, 625, what's the square root of that? 25. So 25 times 25 gives me 625. So our c, or our hypotenuse, is going to be 25 centimeters. All right, so now what I want you to do is, this is the exact, going to work the exact same way as the first two. I want you to go ahead and pause this. Do your a squared plus your b squared equals your c squared. Like I said, side across from our right angle we know is our c. So make sure you know that you're looking for c and not a or b. Doesn't matter if you put 12 or 7 first because we have our commutative property of addition. So go ahead and pause this, work out 3. And I think I talked long enough for you to go ahead and pause it. You might be have unpaused it already and are just waiting for me to stop. All right, so by now, you should already pause this and gone through it. If you haven't, do it now because I'm going to go over it. All right, so we know a squared plus b squared equals c squared, where a and b are those sides formed by this right angle. All right, so our a squared, so I'm just going to pick 12. You could have picked 7, as long as they are your a and your b. All right, so 12 squared plus 7 squared is going to give me that missing side length squared. So 12 times 12 is going to give me 144, plus 7 times 7 is going to give me 49, is equal to our c squared. So then we can go ahead and say 144 plus 49, let's try that again, 144 plus 49, so 193 is equal to c squared, but we don't want c squared. We want to know what the length of the side is, right? So our last step, we're going to go ahead and take the square root of both sides. We know that the square root of c squared is just c, because c times c gives me c squared. That's going to be our side length. And then we want the square root of this 193. And this is why a calculator comes so in handy, because sometimes with those square roots, and I just want to double check that yeah. All right, so sometimes with the square roots, we are going to get this big long decimal. I want you to go ahead, and in this case, I want you to round to the hundredths position, which means I look at this number after my hundredths position, tenths, hundredths. I say, is this 2, 5, or more? And it is not. So we would keep it 13.89. Is our hypotenuse. Did you get it right? If you didn't, do you see what you did wrong? Did you accidentally put one of your legs in for C? If you didn't, star it, bring these questions to class. We'll work through it. We'll see where you went wrong. All right, so now let's go ahead and go to our next page, and we're going to look at, this time we're doing the same thing. Our Pythagorean theorem is still a squared plus b squared equals c squared. Real quick before we start, because they want us to assume that these are right angles, but further on this week, we'll talk about determining whether or not they are, so I don't like that they didn't give you the symbol to say, this is our right angle. So go ahead and put those right angles in. All right, so our Pythagorean theorem is still the same. We have a squared plus b squared equals c squared. But what do you notice about these triangles? And I think I already said it. That's right. They give us our hypotenuse, but this time we are missing a side length, and I'm just going to pick it that it's b. So we're still going to plug in the information this time, but we're going to be missing our b squared. So what we're going to go ahead and do is we're going to plug in our a and our c. So we're going to say 5 squared plus the missing side length squared is going to give us 13 squared. So we can still go ahead and square our numbers that we do have. So I know 5 times 5 is going to give me 25, plus our side length that we don't know squared equals, and 13 squared, I just want to double check, I believe is 169. So 13 times 13 is indeed 169. So this time, before we added them together, this is your really only big difference. We're going to go ahead and subtract that 25 from both sides. And let me scroll down. We know it cancels on this left side, so all we're left with on that left side is b squared. And b squared is going to be equal to 169 minus 25, so 144. And you could plug that in the calculator, but off the top of my head, what number times itself gives me 144, I know is 12. So we're going to take the square root of both sides. The square root of b squared is just b, because b times b gives me b squared. So b equals, and also the square root on our right side, the square root of 144. What number times itself gives me 144? It's going to be 12. All right. So I'm going to do one more, and we're going to do the same thing like before. I'm going to have you pause this and go ahead and attempt it on your own. So again, in these examples, we have a hypotenuse and a side, and I'm just going to call our missing side b. So we're going to go ahead, start with our Pythagorean theorem. Leg squared plus our other leg squared equals that hypotenuse squared. And you could have named your missing side a, as long as that missing side was a, it was a leg and not a hypotenuse, because we have our hypotenuse, or side across from our right angle. So I'm going to go ahead and plug 6 in for our a, so 6 squared. Oh, and real quick, because this is important, we have inches here, so that b, that missing side length, is 12 inches. So it's important to make sure we know when we're talking about lengths what we're talking about. So now let me jump back to 5. I'm sorry, I just wanted to fix it. All right, so a squared, so our 6 squared, our leg squared, plus our unknown leg squared is going to give me that hypotenuse squared, which is that 10 yards across from our right angle, so 10 squared. Well, I know 6 times itself is going to give me 36, plus our unknown squared is going to give me 10 times itself, which is 100. All right, so now we can go ahead and remove this from both sides, because we know we get rid of addition with subtraction. And this cancels on our left side, and we have b squared is equal. And I'm going to go ahead and work this out for us. 10 minus 6 is 4. We're going to borrow. 9 minus 3 is 6. And 0. All right, so then our last step is to go ahead and take the square root of both sides. And I know b times itself gives us b squared. So b times b is b squared. So the square root of b squared is just b. And go ahead and take our square root on that right side. And these may get more complicated, but I can tell you off the top of my head that 8 times 8 is 64. So our missing side length is 8, and we're talking about yards. So now what I want you to go ahead and do is I want you to go ahead, and if you're not done copying these, go ahead and copy these. And then I want you to pause this and work out 6.